Hello class, these are our notes for section 6.4. Today we are comparing quadratic and exponential functions. So let's remember from the last time we took notes here that quadratic is when our variable is raised to the second power. It's degree 2 is what we call it. So we're basically looking for something that's x squared. When we talk about an exponential function, we mean a function where the exponent is the variable. So when I'm comparing y equals 3x squared and y equals 2 to the n power, 3x squared is going to be our quadratic because our variable is being squared, and 2 to the nth power will be exponential. And so remember, this is like 1 times 2 to the n power. So our start is 1 and our growth factor is 2. That tells us that we are doubling every single time. So just try to make sure we get some review in from our previous unit. So we're going to go ahead and we're going to fill out these tables. So if we have n equals 1 and we have 3n squared, that means 3 times 1 squared, and 1 times 1 is 1. So 1 squared is 1. 3 times 1 is 3. 3 times 2 squared, well, 2 squared is 4. 3 times 4 is 12. 3 times 3 squared, 3 squared is 9. So 3 times 9 is 27. 3 times 4 squared, well, 4 squared is 16. 3 times 16 would be 48. Let's see, I think I want to erase that exponent. It's kind of bugging me there, and we'll fix that. What are we up to? We are up to 5. 3 times 5 squared is 3 times 25. That's going to be 75. 3 times 6 squared is 3 times 36, and that's 108. 3 times 7 squared is 3 times 49, and that's 147. And last is 3 times 8 squared. That's 3 times 64. And let's see, 60 is 180, and 12, 192. All right, we filled out our 3 to the n squared column. So remember, every time we're raising something to a power like this, like we have to do our exponent, I guess is what I'm getting at, before we multiply by 3. So make sure we're following order of operations. So 2 to the nth power I actually think is going to be easier for us because this is fresh in our minds from the last chapter. So let's remember that 2 to the first power is 2. 2 squared would be 2 times 2, that's 4. And then because this is really doubling each time, like 2 to the third power means 2 times 2 times 2. Well, that's a 4 times another 2. What I can do is I can just kind of go down this table and just keep multiplying by 2 because that's my growth factor. So I'm just going to keep doubling those values. So 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 128. And then 256. And then a cool trick is once you filled out a table like this, just to check your answer, just check the last value. So with the calculator, check and make sure that 2 to the 8th power equals 56, or sorry, 256. And then because it checks out in your calculator, you'll know if that last one is right and you've gone through and you've doubled all of them, you'll know that they're all correct. So now that we have our table done, let's see what we're trying to look at here. So we know that really the whole crux of this section is it says we are comparing quadratic and exponential functions. So part B is asking us which is bigger at the beginning. So if I'm looking at the n equals 1 row, my 3n squared is bigger. If I'm looking at the n equals 2 row, 3n squared is still bigger. If I'm looking at the third row, it's bigger. If I'm looking at the fourth row, it's bigger. And the fifth row, and even the sixth row. And after that, though, it shifts, doesn't it? Like it's still bigger here, but once we reach row 8, we can see that the second one, we can see that the 2 to the nth power is bigger. And it's just going to keep getting bigger, right? When we double 256, we're going to get like 512, and this one is not going to grow nearly as fast. So it's kind of interesting. You really think at first that the quadratic is going to give you a bigger answer, but eventually the exponential function is overtaking it. So I'm going to write something exactly like that. I'm going to write at the beginning, 3 to the 3, what was it called? 3n squared. 3n squared is larger, but for larger values of n, 2 to the n is bigger. Okay, and maybe we want to put some real numbers on this. So what I can say is that I'm looking at from 1 through 7, right? It's always bigger. And then from 8 and up, it's not. So I think I'm going to say larger values of n. I'm going to say n is greater than, let's see, I guess when it was greater than or equal to 8, so maybe greater than 7 because 8 is greater than 7. I could say that's my cutoff. And then I could say n less than or equal to 7 here, right? And I'm not really sure where the cutoff is, right? Like maybe 7.5, one of them still bigger. But we could add in some extra information, I guess is what I'm getting at there. And so really, I mean, there's a lot more numbers, right? There's 9, there's 10, there's 11. So it might look like for most of our table, 3n squared is bigger. But when you really think about the scope of numbers, our 2 to the nth power is going to yield bigger answers most of the time, right? Like there's way more numbers bigger than 7 than there are smaller than 7. What does the equation grow by? It grows by a factor of 2 each time. And remember, we're calling that the growth factor or the multiplier. So just kind of going back and reviewing from our previous unit. What does the other one grow by? So this is a really interesting question. What does 3x squared grow by? So to figure out a growth factor, you're really dividing consecutive terms. So if I look at my consecutive terms here, I have 3 and 12, I have 12 and 27, and you're always doing like the second one divided by the first one. So 12 divided by 3 or 27 divided by 12. So we're going to look at a couple of those. So if I have 12 divided by 3, I'd have a growth factor of 4. My next term was 27. 27 divided by 12, because remember we're dividing the 2 in a row, is only 2.25. If I look at the one after that, I feel like it's 48. Yep, 48. So if I do 48 divided by 27, it's only 1.78. If I look at, let's see what's after 48, 75. If I take 75 and divide by 48, now I am down to 1.56. And so those values are going to keep decreasing until they get closer and closer to 1. So we are multiplying by different amounts each time. It multiplies by different amounts each time. So it doesn't really make sense to use some of the same language for them that we do for exponential functions. The factors are getting smaller and closer to 1. So blank equations will always grow faster than blank equations in the long run. So in the long run means, it could mean for very big values of x or n or whatever we're looking at. So which ones grow faster? Well, we saw exponential functions grew faster. So I'm going to write exponential functions grow faster than, and they grow faster than lots of functions, right? They grow faster than linear functions as well. But really here we're talking about quadratics. So they are going to grow faster than quadratic equations in the long run for bigger values of x. So this is really our main idea. You're going to see that your homework is a lot of comparing quadratic and exponential functions, so that's good. We get to go back and do a little review of exponentials. And then we're also going to have some review of earlier this chapter. So you'll be looking at number patterns as well and trying to make sense of those. So as always, if you need help, please make sure you ask.